Okay, so complex fractions, what you're going to need to be able to do with these is simplify them, okay? So a complex fraction is a situation where you have a rational expression within another rational expression. So fractions inside of fractions. We don't like that. It's messy, difficult to work with. And so there are a couple of ways that you can go about tackling the simplification process. And one of those is, working with your numerator separately from your denominator, getting least common denominators, and then using the idea that when you multiply, or excuse me, when you divide a fraction by another fraction, you multiply by the reciprocal, which I think is what most of you actually have learned, which is to clean up the numerator, get a least common denominator, and then use this technique. Okay. That's great. It's not as efficient as what I'm going to show you. Okay, so the ideas that we're going to use right now are going to be slightly more efficient, and I think will get you there a little bit quicker. Okay, so I do want you to look for the least common denominator as you would have before. Okay, so we're going to keep that. We're going to keep that that idea going. All right. So in my first example, I have a fraction with a denominator of x, and then I have another with a denominator of x minus 1. In my denominator, though, lucky for me, I don't have a denominator within that fraction, so I'm just going to say over 1. So the least common denominator between these three things is x times x minus 1, and technically times 1, but I don't need to write that. So what I'm going to do is multiply by that least common denominator, x times x minus 1, in both my numerator and my denominator, okay? But there's another way I want you to think about this. I essentially want to get this x out of the denominator. I want to cancel x. How do I do that? I multiply by x. But then I also have to multiply by x in the denominator. I want to get this x minus 1 out of the denominator. How do I do that? I would multiply by x minus 1. But then I also have to multiply by x minus 1 in my denominator. I don't need to worry about that. Dividing by 1 is not a problem. Okay. So I'm multiplying my numerator and my denominator by the least common denominator of these guys, x times x minus 1, because that will help me to eliminate the fractions within the fractions. Okay, so once I have that, I notice that I'm multiplying my entire numerator by x times x minus 1. So this whole thing needs to be distributed to both terms in my numerator. Okay. Now this step would be a step we don't necessarily want you guys writing. All right. So this is going to be sort of my background work, and I'm only going to do it for the first example. I will not do it for the other two. I have 1 over x, to which I am multiplying x times x minus 1. Minus, I have 1 over x minus 1, to which I am multiplying x times x minus 1. So we don't want to see this step, this distribution step, because the point of this is to become more efficient. But this I'm doing to hopefully get you to see what's happening, what's going on in the background. And then in my denominator, I have x plus 2 already as a quantity, to which I am now multiplying x and x minus 1. I don't need to write over 1. There's no reason for this, okay? And then when I come back up here, I notice that 1 over x times x, those guys cancel, as long as I note that x cannot be 0. But that shows up down here, right? If x is in this denominator, x can't be 0 anyway. So we're good. And then I have 1 over x minus 1 times x minus 1. So those factors cancel, as long as I say that x cannot be 1, right? But again, here it is down in my denominator. X can't be 1 down here anyways, so we're good. So by doing this, we've covered all of our bases with domain as well. All right, so let's go ahead and rewrite our numerator. Now, this is the step that we would expect. In fact, what I'll do is go back through this example and cross off what I wouldn't want to see from you. So x minus 1 is all I have left in that first term, minus I have an x left over in the second term, all divided by, I don't love the order that this is written in. I'm going to start with the x, then the x plus 2, and then the x minus 1, because a times b is b times a. I can rearrange. I have a little bit more cleaning up I can do. X minus x cancels, so all I have left in my numerator is -1. And so I have -1 over x times x plus 2 times x minus 1. And if you'll notice, your domain is that x can't be 0, which was true at the beginning. X can't be -2, which was true at the beginning. I couldn't divide by -2. Or sorry, I couldn't divide by 0 if x is -2. And then x can't be 1, which was also true at the beginning. So the domain is the same. Okay. But what we would like to see you do is in this first step here, when you're distributing the x times x minus 1, know that the reason you're doing this is to cancel the x's. So all you would be left with in this first term is x minus 1. And when you're distributing this thing to the second term, the reason you're doing that is to cancel the x minus 1. So all you'd be left with is x. So this is the step we don't necessarily need to see. I know some of you are going to want to show it for a while, but it's not a requirement. We're not going to put it in the rubric. All right, so second example. What is the least common denominator here? Well, I want to get rid of x plus 1. And I want to get rid of x minus 1 out of this denominator, which also takes care of that denominator. So we're good. All right. Again, we're going to distribute. And in the distribution process, we're going to be able to cancel the x plus 1 in the first term. And we're going to be able to cancel the x minus 1 in the second term. So I'm just working on the numerator first. So we have 2. The x plus 1's cancel. We're left with x minus 1. Minus 3. The x minus 1's cancel. We're left with x plus 1. Divided by, and now if I multiply into the denominator, right? 4x plus 1, and then the x minus 1's cancel. So we're left with just 4 times x plus 1. Okay, so now I'm just going to do some distribution and clean things up. 2x minus 2 minus 3x minus 3, all divided by 4x plus 4. Okay, so 2x minus 3 is negative x. Minus 2 minus 3 is -5. Now both of those terms are negative, so they should both be in the numerator. And then if you want to factor the negative out, you can make the entire expression negative, leaving you with x plus 5 over 4x plus 4. You just got to make sure that that negative is now out front of the entire fraction, the entire rational expression. All right, and I only have one more example to do. So when I do this third example, I think you should have enough practice to go through these. All right, so I've got 4x plus 1 over x and then minus 2, but I don't have a denominator on the 2. So I'm going to go ahead and put a 1 there. Maybe not needed, but would be a good idea to just kind of keep things in line. And then I have a denominator with a denominator of its own of x plus 2. So what are the things that I'm trying to get rid of? Well, I want to get rid of this x. And I want to get rid of this x plus 2. There's no need to get rid of 1. Okay. And we're not really getting rid of anything. We're just sort of rearranging. Okay. So again, we're going to go through the distribution process. Where we have, excuse me, I'm trying to find my marker that I just used. There it is. So we have x times x plus 2 being multiplied into the first term. into the second term, and there's nothing to really distribute here. Okay. All right, so again, the point of this was to cancel the x in the first term. So I have 4x plus 1 times x plus 2 is all I would have left because the x's would cancel. Minus 2, I don't need over 1. Nothing cancels here. X times x plus 2. All divided by 3x plus 3. But the point of this was to cancel the x plus 2's, so times x. That's all that's left. All right, I'm actually going to see if leaving my denominator factored might help. Let's go ahead and expand the numerator and just see what happens here. We get 4x squared plus 8x plus 1x plus 2. And then distributing a negative 2x gives me negative 2x squared minus 4x. I don't think it's really going to help us much. We'll take a look. And then down here we have x times 3x plus 3. And by the way, most of these times when you're working with these within limits and calculus, you're going to want that denominator to stay in factored form. And you'll see why as we do more examples in the calculus. Okay. Let's combine some like terms. 4x squared minus 2x squared. So 2x squared. This will be 9x minus 4x, so plus 5x plus 2. Oh, we might be able to factor. And then we have x times 3x plus 3. All right, so let's go ahead and try AC method on this numerator as some good factoring practice, okay? So over here to the side, a times c, that's going to be 2 times 2, which is 4. I'm wondering if I have two numbers that multiply together to give me 4, that add together to give me 5. And I sure do. It's 4 and 1. So let's go ahead and rewrite our numerator as 2x squared. Remember, we're going to make the 5x, we're going to make it 4x plus 1x. And since everything's positive in the numerator, I can just group my like terms right here, my two groups together here. So right, I group my first two terms and then I group my second two terms. Common factor here is 2x, which leaves me with an x plus 2. And then I've got the x plus 2 here. Alrighty, and then my common factor in the numerator is x plus 2, which leaves me with 2x plus 1. But even if I factor the 3 out here and make this 3x times x plus 1, none of my factors cancel. But that's okay, because if they had, right, if I'd be able to cancel any factors here, I at least had the practice with the AC method again. All right, so what you're going to want to do with complex fractions and limits, all right, the whole idea here is to simplify the complex fraction. That's your algebra. All of this is the algebra. But with limits, the idea is that you're hopefully going to be able to get rid of a factor in the denominator that might be causing you an issue. Okay, so that's why I went through the factorization here to see if maybe I could find a common factor. All right, so that's it for complex fractions. That's how you're going to want to simplify those, the most efficient technique to do that.